purely as high school students because you are not that age, but anyways. So 4.5 notes.
Are we going to go over this?
You'll see, yes. Okay. So the first thing we basically learned in 4.5, and it's so weird because I stopped using the textbook to make these, and they're still kind of hard to see. So anyways, I'm trying to make the notes clearer for you guys, but anyways. So hypotenuse leg. I want to point something out about hypotenuse leg. If I were to call these angles and sides, what would it be?
Angle side side.
It would be angle side side. Okay? If you notice that the order would be angle and a side and a side. Okay? So angle side side does not work unless it's what?
The hypotenuse and the side.
Unless the angle's what?
90 degrees.
90 degrees. So if this is 90 degrees, then it works, but we don't call it angle side side. We call it what? We call it HL. Okay? So we don't, even though that works, we call it HL.
So let's say we're like looking at a triangle. How do we know which one is the starting point?
What I would recommend is you just identify the sides and the angles, okay? And then from there, figure it out. So that's an awesome question. And so, for example, if I had a triangle, okay, and we always have two of them, but we kind of just look at the one because they always match. But if I have this, and I have this, and I don't know, I have this. Okay, so what if you're confused about how to identify this, some people look at this and they go, I know that it's this. Okay, yes. Okay, do you want to grab it? So some of us know that that's what that is without looking at it. Other people are a little more confused. So to answer your question, what I would do is if I'm unsure, I would say this is a what? An angle or a side? That's an angle. This is a what? An angle. And this is a side. So then, where do you start? Where you start is the shortest possible way. So if I started here and I went around, that is not the shortest possible way. What is the shortest possible way? Angle side angle. Did that help?
Kind of, but like, what if? Oh, wait,
okay. So another one, and I didn't really go over this very much. I mean, I just kind of told you and then assumed we would be good. Okay, so say we had this one. Again, we would say this is an angle, that's a side, that's a side. And once you have them written there, the shortest possible way is what?
Side angle.
Do you see it? Okay. So just putting the letters on there might make it a lot easier for us. Okay. Whereas some of us can look at this without the letters and see it. Just throw them on there, and I think it'll make it easier. Okay. And that's essentially what I did here is I did it, and then the shortest possible way would be this. Okay. You wouldn't want to go all the way around. Yeah, I mean, it's still angle side side in this case, but okay. The next question says, what information would we need to do hypotenuse leg?
The length of the R and then the N.
Okay, we would need to know that this is what?
9.
9. Do you see the numbers on there? And we'd also need to know that what?
M to N is 5.
And that this is 5.
Or S, I can't tell.
Yeah, well, I think it's a number. Okay. And then that would give us our two sides and our angle. Yeah. So you have to figure out this is the shorter leg. So and this is the shorter leg. So just visually I saw it. I mean,
I was like, whatever numbers they give you, that's the length you use.
On this one, yeah. Usually we don't get numbers. Usually we get, the little marks. Okay. Yeah.
Would that also kind of be like a rotation and a reflection?
Yes. And that's what they're trying to, that's what this whole chapter, the pre-chapter, the chapter before kind of says that if you do a transformation, a rotation, or a reflection, the triangle is still congruent. So you could do all three of those things and you still could have congruent triangles, okay? So I think what we've been struggling with, I think once I tell you the postulate, most of us can do the homework. Some people yesterday were asking for the homework before we even did the notes because they're like, we get it. You give us the postulate, boom, we go. But I think our proofs are where we're struggling. The written part is going to be proofs on the next test, okay? We have one more section, so I'm thinking it's like Wednesday or Thursday next week. Okay. That'll be the first grade in the next 9 weeks. Okay.
Well, just remember, you have all this homework to help it.
And, or it could be, your, yeah, and your second grade is all the homework. Okay. We've been doing pretty good on our test.
I don't normally complain. It's just, proofs are hard.
Proofs are hard. Now, let me tell you, every proof that we're going to see is is different, but this is how it's the same. Basically, the only thing you know how to prove is what?
If it's right.
Or wrong.
Or wrong.
Or given.
If it's given, I know how to do it.
What is this whole chapter about?
Triangles.
The only thing you really know how to prove is what?
Triangles.
Triangles are what?
Triangles.
Congruent. You basically, the only tool you have is to say that this triangle is the same as this triangle. Every proof we do, at some point, you're going to say that this triangle is congruent to this triangle. Okay? And then once you do that, you can say, what about their parts? And then that's the next thing you can do. So know that that's the heart of every proof that we're going to see in this chapter.
It's not going to be terrible.
Why can't we just measure each angle and say, this is not equal to each other?
So the point of this is not what's the easiest method. The point is, honestly, geometry is about writing proofs. Okay? We could have in Algebra 1 have proofs, and Algebra 2 have proofs, and pre-calculus have proofs. We could put proofs in every single mathematics. If you study mathematics in college, once you get past calculus, all you do is write proofs. That's it.
What year is calculus?
For us, it's 11th grade. If we pass everything. If we pass everything and go with the thing.
So if you study mathematics in college, you're basically studying proofs. If you're a mathematics professor and you write books that are proofs. Okay?
Oh.
When a mathematician puts out a paper that blows the minds of a bunch of different people, it's like a 30-page proof. Okay? So they decided, the powers that be said, let's put proofs in high school. And everyone said, where would we put them? Well, let's put them in every subject. You could. Okay? We could ask you to prove the Pythagorean theorem, to prove all these different things. They don't have you do that. They said, let's just throw it in geometry. Okay? And then geometry becomes about proofs. So there's not. But there's non-Euclidean geometry, and if you're a math major in college, it's called non-Euclidean geometry. So it's geometry of round things.
Wow.
Yeah. That's sort of math.
Okay.
Not necessarily.
So it's in non-Euclidean geometry, parallel lines intersect.
What?
I was like, wait, what?
So
Don't they already?
not parallel lines.
Parallel lines.
Did I say non-parallel lines? I said that wrong. Parallel lines intersect in non-Euclidean geometry.
Parallel lines intersect?
In non-Euclidean geometry. That's not what we're studying.
Move on it out.
Yes.
Let's move on to another, please.
So, in other words, geometry is about proofs. If you ask an adult who went through geometry, give me one word to sum up geometry, and they'll go proofs.
Hard.
Okay. Okay.
Unnecessary. What? What?
So this, and when I was a kid and I did mazes, I always started at the end of the maze and went backwards because I found that the easiest, right? Let's do that with the proof. Okay. We got to think about going backwards. So this proof says, write a proof that shows that the triangle is isosceles. Okay. So we have this big triangle here, and our goal is to prove that the triangle is isosceles. In order to prove that the triangle is isosceles, and I gave you guys space over here to write the proof, we need to know, if I start backwards, I can start by saying triangle ABC is isosceles. Why am I putting it at the bottom? Because we're going backwards. Our last step is to say, therefore, the triangle is isosceles. Okay? I know, I couldn't either. I had to look over. In order to show that the triangle is isosceles, we have to show what?
That the sides are the same.
Which sides?
A to B and C to A.
So I need to say AB is congruent to AC. Okay? If it was given, if that was given, we would write given and we would be done. Okay? So that's our goal. We'll get there. Okay?
Don't we also have to make sure that angle
You
C
do the
and D are
statements backwards
congruent?
and then you do the reasons forward, right?
Well, the only reason I haven't put reasons there is because we haven't gotten that far. Okay? And honestly, I think the reasons just kind of, if you know the definitions, they just happen. Really, this is the hard part. The statements is the hard part. The reasons is like you know it or you don't, in my opinion. Okay? We do not have to show that angle C is congruent to angle B, though if we did, that also could be that would be the step before this. Okay? All right, so how do we prove that AB is congruent to AC?
That AD and AE are congruent.
If I can show that AD is congruent to AE,
That's given.
and that's given, okay?
Oh, yeah.
So we can now that we know if we do this and we do this, our proof is done, okay? If we can show this is true, and then this is true, right? And our proof is done. Now we have to show, how do we know that this is true? Okay? So
Yeah.
Okay, so AE. Oh.
now this is where the roadmap comes into play. Now this is how I would advise to do the proofs. Okay? Which way is Cleveland?
North.
Point.
North.
That way. What?
Where's Cleveland?
That's what I was like.
No. It's moving down this way. So that sun rises in.
So if we got in a car and we didn't have a map, and our goal is to drive to Cleveland, okay? You could drive. Some of you don't even know which direction we drive. Okay? We drive, we hit the Ohio River.
We asked somebody
Still don't know what direction that is. That's south.
Then we what? Then we got to turn around. We drive, we hit Lake Erie.
Then we have to ask
Turn.
Okay, then you turned right and you hit Buffalo.
You need to ask for directions.
Okay, so my point is, you have no idea where you're going. You just start driving. That's what we're going to do with this proof. You cannot put too much information in a proof. You can only give too little information. So let's start. Yes.
Since we say that angle FEC is the same as FCC, so there's a straight line and a right angle, so that we get right angle.
Last year, but not.
I did a lot last year, so I can straight there.
I don't know if we could say that. All right, so let's refocus. What can we say? Let's just start driving. Maddie, what can we say?
We can say that A to C is, A to E is congruent to A to B.
Okay. And again, I have no idea where I'm heading. I'm just writing things down. What makes me allowed to say that?
Given.
It's given. Oh my gosh. Okay. What else can we say? Hope?
Angle ADF and AEF are congruent.
Angle ADF is congruent to angle AEF. ADF,
Yes.
No, I can't see.
AE is congruent to AD.
Couldn't you say those are all congruent?
What is my reason here?
Given.
Given.
What was given?
Yeah, because it was 90.
Yeah, because it's already marked on there.
It's already marked in
Oh, never mind. CF is congruent to BF.
CF is congruent to BF. Okay, given.
Now we have side angle side. Does that help?
Now, I want to point out something. We have side angle side. What do you call them?
Hey, man.
That's kind of rapist.
We should read the trip. All right. We have side angle side, but what's the problem with this side angle side?
The angle is like a whole angle.
Right. It's not. We have a side in one triangle, a side in a completely different triangle, and an angle in that other triangle. So we don't have side angle side.
AF is equal to AF reflexively.
AF is congruent to AF.
This is the thing that just screwed me up. Why do we have to put that?
Okay, so let me say something. We are driving. Brody found Lake Erie.
This is like here.
And my point is, he found something that's getting us closer to our destination. When he said it, I think I could tell in his tone that he knew that was leading us somewhere. It's super hard for me to teach you why that's leading somewhere. Did you know where we were headed when we first started? You could visualize what.
We could go like by Kansas.
Okay, but I'm saying when you said AF is congruent to AF,
Oh, you're talking about math.
a light bulb came on, right? Yeah.
Yeah, because like whenever I'm doing the Pearson, it's like do like the side angle side, like street like that stuff, or side, and then have to do the reflexive, and then it'll go to proving that they're congruent.
Okay. So the beginning, I said that the main heart of every proof is to show what? That what are things are congruent? That triangles are congruent. So he just told us that this is congruent to itself.
Which when it like flips over, it'll land on each other.
Okay. Which means that now I can say what two triangles are congruent.
AEF, AEF.
Triangle AEF is congruent to triangle ADF. How do I know that?
You're smart. Side, angle, side.
That's for parts. We're not there yet.
It's one of the sides.
It's angle side.
Angle side. HL. I'm allowed to use HL because that angle is what?
90 degrees.
90 degrees. So there's no angle side side unless it's 90 degrees, and we call that HL. So what is saying that those two things congruent do for me?
Now we gotta prove that CFE and DFB are congruent, and then we can add those two together and then say that the other ones are congruent.
Okay, so she was lost, and she just found Parma, which is right outside of Cleveland. She found Cleveland Heights. Okay, she knows she's close. Yes. Okay, she can smell Cleveland.
No.
How do you smell that? What's it smell like?
You don't want to know.
A lot of trash and water. Very, very.
Okay, so Maddie, and this proof is pretty long, and I didn't give myself enough room, but Maddie now is saying, why don't we prove that these little triangles are congruent?
So F to C is congruent to.
CF screwed the BF.
Now, we already actually have that written down, so we don't have to write it again.
No, we don't. Where do we have that written down?
Why do we?
Number 31.
Somebody told me to write it down. Now, we didn't need that yet, but somebody told me to write it down.
I did.
Jonathan?
We also know that angle D is congruent to angle E.
Okay, we're not allowed to call it angle D
What?
because there's two angles.
Okay.
You got
Angle angle DBF.
Angle CEF, and you might name it differently, is congruent to angle.
D.
How do you know?
It is supplementary complementary.
You're not doing that angle.
It's
Yeah.
Supplementary.
Yeah, because supplementary, because.
So, Mr. McConnell, I forget. How do you, what's the difference between supplementary and complementary?
Complementary means two angles add up to 90 degrees.
And then
That's
supplementary is
complementary.
one angle.
Okay, so this is supplementary.
Okay.
Supplementary angle.
I like supplementary.
Supplementary, that's what I said earlier.
So
Yeah.
supplementary angles. Sup.
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 Okay, so then now we have side, we have channel, and we need to figure out another side. I'll figure out another side.
Tommy.
Now,
Tommy?
we know that E to F is the same as E to F.
Side DF is congruent to side EF or segment. How do we know that?
Okay.
Because C, B, T,
I
no,
said that.
CPCTC.
Cats, puppies, cats, tails.
Oh, cat.
Why cats? Why cats?
All things that are good in soup.
Cat.
Oh, God.
3 cats and soup.
That's violent.
Chase is some Asian meals right now.
EF.
Yes.
Hold on, turtles. If we only have, so now we can say,
Okay, so again, some of us are really lost, but if you just start proving triangles are congruent, okay, it helps you. We were not able to show that the little triangles are congruent without showing that the bigger triangles were congruent, okay? But now that I know these are congruent, I can say that this side here, which I'm gonna have to put 4 marks on, is congruent to this side here. Because of corresponding parts of congruent triangles are congruent. And because I have that, okay, so because these two big triangles are congruent, I can say that these parts are congruent. I already know that those parts are congruent. And we know that this is 90 degrees. So now I can use what to say that the little triangles are congruent? HL. Okay.
Triangle.
Triangle CEF.
Congruent triangle.
BDF.
Why'd you make a paper airplane box?
Because of HL.
Because of HL.
Then we can go to AB is concurrent to AC, right?
Almost.
One more step.
Can't we just add them now?
Uh,
Substitution?
let's not.
Do a paper airplane, that mean this.
I have a feeling that you started it.
Can you zoom in, please?
Zoom into what? Which one? The picture or the?
On the proof, the bottom.
So now, so we can do A to C plus B to B is equal to A to B.
Now she wants.
All right, so we're super close. We're at the suburbs. Okay. So our goal again was to show that this length here was congruent to this length here. Okay. We now know that this is congruent to this.
And the bottom here.
And that these are congruent. So somehow we have to say that if those parts are congruent, then the whole thing's congruent. So how do we say that?
Triangle ABB.
ABB plus.
Say it again.
If you add the
A to
side
B plus A to C is congruent to A to
D to B.
Okay.
Say that.
Say it one more time.
Okay. How about we do A to D plus D to B is congruent to A to E plus E to C.
Okay.
Yeah,
A to what?
that's what I'm saying.
A to D. I'm listening.
Segment A to D is plus segment D to B is congruent to
A to E,
segment A to E
E to C.
plus
Plus
E to C.
and you can say that because substitution. And then you can say that
segment
Can you zoom in
addition
on that?
plus.
oh
Yeah.
yeah, that's what then you can put D to B where A to C.
What was it?
Segment addition postulate.
Well, I think actually that makes this sub. That's what makes this allowed.
Yeah,
That's allowed.
right? Oh, we have to do the proof for that.
I think we skipped something.
But it works though, doesn't it?
And you wrote it down, so you just.
That's right.
Unfortunately, I didn't give myself enough space, but I think we should have snuck in here. AE is congruent to AD.
Do we have that?
Yeah, we do.
Okay.
It's the very top.
Very top.
And EC is congruent to DB. And I know we have these.
We don't have the ECD. Yeah, we don't have the ECD.
Okay. So therefore, AE plus EC is congruent to
Let me just sneak that in.
AD plus DB.
Wait, so what would like if we did the EC to and then the DB one? What would the reason be?
CPC.
What's the reasons we're allowed to say that?
Yeah.
We're allowed to say this because of, C, P, C, T, C.
What about the one below?
The one below it, oh, I did that wrong. This one was given.
Yeah, that one's given, the other one's CPCTC. That's what about.
And then this one is angle,
Addition posture.
yeah. No, it's,
Or segment addition.
Yeah. I don't think that's right.
I don't think it's right either.
Because then we
Angle addition is when you say that AC is congruent to DB. That's angle addition.
No.
Segment, thank you.
Well, then what is that? Substitution? And also there's no addition in that.
Yeah.
Yeah, there
There's
is.
no, in his version.
Oh.
We did this.
Something that says that if 5 equals 5 and 2 equals 2, then 5 plus 2 equals 5 plus 2.
Or the
Like something idea.
I kind of like transitive.
wait, I'm pulling out my
Because
words.
A equals two, that's something about that's A equals B.
Yeah, I got the words out, don't worry.
What do you think?
Can I go on the Kahoot?
It's transitive. It's transitive. It means
You like transitive?
Wait. I got
A equals B, but then B equals C. That means that A has to have a C.
So you like transitive here?
Yeah.
transitive is A. If A equals B, B equals C, then A equals C.
So if we have something and we have another thing and we put them together. So honestly, on this one, on that statement, I think I would accept transitive. I think I would accept segment addition. You might get away with that.
Why not definition of a isosceles triangle?
Yeah,
That's the one.
That's the last one. We're talking about what makes us allowed to say this.
oh wow.
I think you could say, and sometimes you,
Congruent?
yeah, addition of congruent parts. I mean,
Make one up.
you could make one up, okay? Sometimes you can get away with things on proofs that otherwise you couldn't, okay? So, right. What you wouldn't want to do is leave it blank, okay? You almost probably could get away with anything on that one. And then, so that all should have snuck in. And yes, I did repeat some stuff, but I think repeating the things kind of made it so it made logical sense of what we were getting at. I would have snuck all that in right here. Okay.
Wait a minute.
And that took care of this, and that reason is over there. And then finally, triangle ABC is isosceles.
I'm just gonna say that it's not AC is congruent to DB, or DC is congruent to DB.
Definition of isosceles.
Say that again.
So, right here,
Uh-huh.
you have AC and DB. AC is that whole side, DB is this thing right here.
Do I have it wrong?
Yeah,
Oh,
you did.
I did it wrong. So that should have been AB, right? Thank you. No. So that the final last step is to write what? Definition of isosceles.
Calm down.
Well,
I technically said it
and then
first.
he wrote it down. Okay, let's flip the paper over.
Mr. McConnell, before we start this next group, can I use goodies left?
I already said no, so I'm gonna stick with it. Can you wait?
Yeah.
What?
I just don't want you to miss this proof.
I can go real quick.
Okay, go ahead. Go ahead.
1, 2. Okay, you're back.
Okay, the bag here. It's not blue.
No, they can't.
So yesterday,
Geometry.
Yes.
Just talk about random geometry stuff, so when he comes in, he thinks he stuff.
Yes.
That's honestly.
So like while he's walking in, we're just gonna be like.
so you woke up from, wait. You woke up from your nap to share that with the class?
I was not asleep.
No.
I was listening to everything that's in my bottle,
Mhm.
actually.
What's the last proof? What's the last proof without looking at it?
Definition of isosceles triangle.
Look at your paper.
It was.
What's the first one? The first. Ooh.
The first proof said,
Given. Shut up, Ben.
Shut up, Ben.
It's always given.
Yeah.
Well, he didn't know that.
What's the third? What's the fifth proof?
And that's how you do that proof.
Yeah. Okay, move on to the next question. Okay, next question.
Hurry up.
That was my hand, I walked.
All right. So yesterday, I don't know why we'd have a cell phone in our hand. Yesterday, we started to do that paper and I was going to do the proofs. You posted some stuff online. We're just going to move on from that. But what I decided to do is they're now in the notes. So when someone said, hey, when are we going to do those 2 other proofs? Well, they're in these notes right here. Okay. Those 2 problems that we had left from yesterday's sheets, this is one of them and the other one's on the other thing. All right, so we have to prove that triangle JKL is congruent to triangle LMN. A flow proof. The light, that made it worse. Dalton, stop. Okay, so I agree. A flow proof, if I took this thing and made it into a flow proof, what we just did, basically I would just be cutting it out and I'd write this statement and then I'd write comma and then I could write this statement, comma. I could put squares. I could put them in squares and draw arrows. Yes. Not both lights, just the front ones.
I can't see it anymore. Wait, turn your light.
That might actually be a good idea.
I'm gonna fall asleep.
Yeah, it works.
I'm already tired.
Okay, that's the point.
Honestly,
It doesn't, it's not that much.
Okay, let's go.
All right, so try the backlights back on.
Oh, that word.
You guys are lying. All right,
Okay.
so I am not going to do a flow proof. Okay, sit down, Dalton. Okay, I'm going to go ahead, and I actually gave you guys space down here for this proof. We're going to try to prove that those, Dalton, I just said no.
That was the wrong light.
Switch it, please. Can you just go back to sleep? Can you just go back to sleep?
No.
Lay your head on that table. I'll be better off.
All right, so this one, all we're trying to prove is that the 2 triangles are congruent. If you wanted to, all right, calm down. If you wanted to, we could go ahead and put the very last thing is that triangle JKL is congruent to triangle LMT. And if we feel like we've done everything we need to prove that, then we could be done.
There's T on this thing.
It's not a T, that's a J, excuse me.
Okay, I'm stupid. I thought that little squiggly mark was a squaring mark. And I was about to say, how does that work? But J also looks like a T.
The triangle JKL is equal to square the triangle LMN.
Okay, so we need to now show the parts that we can say are congruent. So if we look back at this proof, and I really hate how small this is, but we showed that those different angles were congruent.
Oh yeah, I have it. I have the big one right here.
Okay.
Okay, so like angles 6 and 5 were in the bottom right are congruent.
6 and 5.
And then J1 and 2 are congruent to each other.
1 and 2.
And then 3 and 4.
Okay.
So it's like, and then 8, 7, 8. So it's like for 6 and 5, it's 1 for.
Got it. Okay, so let's just start saying what we know. Let's start driving. Thank you.
It has like 4, 3,
Okay.
2, 1.
Okay, so let's start driving. First off, let's make sure that we can see that this triangle is what we're trying to show is congruent to this triangle. Yeah.
So this is why we have a roadmap.
You want a roadmap?
Yes, please.
I mean, no, sometimes you don't have them. I mean, I look at it and then boom, I have a roadmap. Okay? But without having years and years of practice,
I need a GPS.
you're not allowed to use a GPS.
But I need it If you don't have a GPS, then I ain't getting
It's
nowhere.
literally just a promise.
Can we just
So,
say
is there
no?
a way to use a car with a built-in
So-
GPS?
Can we
Well,
just say that?
later-
Because
later-
it's
Maybe
now.
they'll
That's a
say J
promise.
to L is congruent to J to L. So
That's a literal promise.
Angle 1 is congruent to angle 2. How do I know?
given.
Promise.
That's given. Angle 5 is congruent to angle 6. Given. JL is congruent to JL. That's reflexive.
Are we not gonna write like
The other
3
angle.
and 4 and
70.
Does reflexive mean common sense?
We don't need to.
Triangle JKL is congruent to LMJ because of angle side angle.
What?
We're done.
What?
Whoa.
Okay, can we all read it, see?
That was simple.
I mean, honestly, when you're proving two triangles
Can you
congruent.
understand how?
Can you
Yes, I
explain
do
that real
understand.
quick?
Yes. So the drawing is awful, but if I redraw it,
You don't understand. He's trying to explain that. Yeah, I know.
oop, we're trying to prove that triangle 1 is congruent to triangle 2.
Okay.
We had that this was congruent to that, so we had an angle. We had that this is congruent to that, so we had another angle. We knew that this side was congruent to itself. They added this other little bar across here for confusion.
Okay.
Yeah.
Confusion.
What?
I am confused.
Guys, please stop.
What is the point of doing like the proof that we did last time with 20 and then this one with 3?
Why does this have fewer parts?
No, why do we need to put 30?
Say again.
Why do we need to put 30?
Why do we need to put so many on the other one? And then we had to put 4 on this one.
So the easiest proof that we'll write is proving two triangles congruent.
Oh, no.
We
On
had
this proof,
4 different triangles are congruent to prove that 2 different triangles.
right, on this proof, I had to show that the little triangles are congruent,
And the big triangle.
the big triangles are congruent,
And then that bigger.
and then the big triangle was isosceles. Okay? So if I ask you to prove two triangles congruent, it can usually be very quick.
So it's like, you said the angle side angle, and then triangle blank is congruent to triangle blank because of angle side angle.
So this next one, let's see if this one, yeah.
How do we know that we don't put like 1 and 2, angle 1 and 2 are like congruent to each other, or we put like 6 and 7 instead of like?
Because 6 and 7 is on a line that is still relevant. The line does not mean anything.
How does the other line mean?
Because that's where the 2 triangles are.
That's where they 2 triangles meet. The other line is just a distraction and confusion. They're trying to screw you up.
Well, that's rude.
What
They're
about
being
3 and
stolen.
There you go.
Slow down.
That's a good admission. They're trying.
They're being
All right.
You fail, Mark.
All right, so first off, what are we trying to prove? Trying to prove that triangle PQR, which is this one, RST. Okay? That's what we're trying to prove.
Okay, this is the one we did yesterday, right?
We didn't, we
We
started,
didn't get it.
we didn't finish it
Yeah,
yet.
this is the one I did.
Okay, so they gave us a bunch of parallel lines. They told us that PQ, which is here, is parallel to RS. When I do that, that means what angles are congruent.
1 and 2 and 4, 1 and 3.
Now careful. It's true that 2 and 4 are congruent.
4 and 5.
Okay? From that, 2 and 4 are congruent. But that's it. I can't say that 3 is congruent to 1 because it's been cut. Okay, it would have to be all the way out here in this whole angle, but it's been cut. So I can say that I don't know, I'm just throwing this out here. Angle 2 is congruent to angle 3. I said that wrong. I totally did that wrong. Angle 4 is congruent to angle 2. Awesome. Alternate interior angles.
Wait, is that 2 and 4?
2 and 4, yep. I think the light off has made it worse.
Yeah.
Can you turn the light back on, please?
No.
Or flip the
Thank you.
lights.
How is this bad though? You guys should
How
know
is
the
this
lighter.
Yeah, I can't see this.
I
You're
can.
just blind. Just leave it at that.
I'm blind.
I have glasses.
I know, right?
I have glasses too, Mark.
Well, you're 500 meters.
All right, so next they tell us that PT here
Yeah.
is parallel to QS.
That is true.
So that means
Angles 1 and 5 are correct.
angle 5 and
6. No.
I think it's a 7.
7. There we go.
Angle 5 is congruent to angle 7. Alternate interior angles. Having a discussion while we're doing this is not going to help.
Just look at these and
But
how
then,
they were.
wouldn't 6 be congruent to 2?
For the same reason, to this one?
Yeah, because it gives Q and R and S and T are also parallel. At the bottom. Q and R and S and T are congruent.
Okay, we're not there yet. So let's do that next. QR, which is here, and ST. Yeah, but you were ahead of me. So that means what?
2 and 6 are congruent. And 3 and
Wait, this is a 4 here. 2 and 6.
Oh, 6 and 3.
It would be 4 and 6.
yeah, that's what I meant. Sorry.
So I really did a disservice by making these so small.
So it is. 2 is congruent to 6 also.
Okay.
2 and 4 and then 4 and 6.
Okay. So he's noticing up here, well, if this is congruent to 4, it's congruent to that, then that. Okay. So,
Can you make it? What is that, the triangle map? We have the angles.
That would be substitution.
Substitute.
Yeah, be
substitution.
yeah. Well, let's not, I mean, we could say that.
2, 2, 4.
That's transit.
You want this to be transitive? I would accept transitive. I would accept substitution because they're both true. Okay.
Told you transit. Yeah, I know.
Guys, shut up, you're both wrong.
He's right.
Nobody.
So I'm going to redraw because I made a mess now of my. I'm going to try to redraw this.
Doing that.
What are you doing on the other side?
I'm trying to redraw it now, and I think I did a bad job. What's true about this, I think what we're going to find out is that, and I see 3 triangles there. Do you see 3 triangles? I think that all 3 triangles are actually congruent to each other.
Yeah, they are.
If I can prove that the first one is congruent to the second one, and that the second,
Congruent to the third one, then you can prove that the first one is second is congruent to the third one.
what Jonathan said. So if I can prove that this triangle here is congruent to this one, And then I can prove that that's congruent to this one. Then I can say 1's congruent to 2, or 3, I mean. So let's try it. So looking at just the first 2 triangles, so if I just do this, I'm just looking at triangle 1 and 2. Okay. And we now know that, right, but we need to know, so I can say that this segment is congruent to itself. Okay, so RQ is congruent to RQ.
Thank you.
You're welcome. Reflexive. And what angles have I found? I found that 2 is congruent to 4.
Well, it says,
We have this side.
it says QS and RQ are parallel, so that's, we put that, and then put the angle as, QS and RQ.
No, that doesn't say.
QS and PR.
PT,
PQ and RS.
PT and QS. Yes.
Short hair.
You know what? Let's go ahead and stop there. Okay. And
Because we only have like 5 minutes.
we only have a couple minutes left. I actually have a couple more proofs that I was going to, 3 proofs that I was going to give you as a notes challenge. We're not going to get to them. We need to do them. We need to work, but I want to kind of overview what we just talked about. When in doubt, what should we do? When you have no idea what to do, what should you do?
Backwards.
Yeah, you can
Start backwards.
start backwards, list given.
Do everything you know.
The heart of every proof is going to have what in it?
This is congruent.
The ending's.
Triangles.
Okay.
That you're going to at some point you're going to use one of those side angle sides or something to show triangles are congruent. Okay. Every proof in this chapter is going to have that. And a lot of times, once you prove that, then you're going to use the cats, puppies, cats, turtles, cats
I was easy small.
for your suit. I mean,
Food.
It looks like two.
I want cat, puppy, cat,
I am going to assign the work. It's going to show up tomorrow's a work day. But we got to fit these proofs in there before this test.
One should be.
Angle 1. Yeah, I don't. Let me tell you why I want to stop. I want to stop because these are way too small to actually work with. So even though I have 3 printed out, I realize we need to print them out full size to work with. Okay? Because they're really hard to see.
Okay, see you tomorrow.
All right.
Or later today.
Yeah.
I will see you. Yeah.
Can't wait.
Actually, no, see you.
All right.
Oh.
How do you want?